Hello everybody, welcome back. I promise we are not going to do 42 more algebra problems. This is just the pocket for your problems if you want to use it. I just wanted to show you how it should look when it's all folded up. So that is to hold all of those algebra problems that we just did. Okay, today I want to start, I'm going to do this backwards. Instead of showing you the wheel first, I want to start with examples. So eventually we will be doing the wheel that we are supposed to do for this lesson. That is item number 11 and 10. There are two of them, so we'll do 10 and 11 when we get through these examples. But I think it will be better to start this time with the problems because there's a lot to learn here. You know most of it, but I think it will be easier for you to see it this way. So let's go ahead and label this page. We want to give our pages a title, and I'm going to call this one Inequalities. Great news is that you already know how to solve these because you know how to solve equations. But there are a few things about inequalities that are just a little different. They're added steps. So we'll take a look at those as we go through these examples. The first one that I want to start with is a one-step multiplication, which you're very familiar with by this point. And it's not. It's a one-step subtraction. It's very early today and I'm still half asleep, I think. But this is the inequality that we're looking at. And first of all, let's just study this. Let's see what this is actually saying to us mathematically. It's saying that negative 12 is greater than or bigger than an unknown number minus 7. So we're used to seeing an equal sign there because we've been solving equations where we found one number that would make the equation true. But in this case, we're going to find a whole range of numbers that will make the inequality true. So to solve this inequality, here's what we need to do. You need to draw the power t. And instead of an equal sign, I know that I have this sign. It doesn't matter. We're going to still draw our power t. We are still going to decide which side is variable and which side is constant. And we are still going to ask ourselves which term needs to move. And it's the minus 7 that needs to move. It needs to go over to the constant side just like it always has. So we're going to add 7. Those rules have not changed. This is one reason that we spent so much time learning these problems. So x is left. Remember, you cancel and then you copy. Negative 12 add 7 is negative 5. And then our last step was to do what? Standardize. And I told you so many times in those lessons, there's a reason for standardizing. Now when you standardize, because you are reversing the x and the negative 5, you have to reverse the sign also. And let me show you how to make sure that you're right on that. You see how the little part of the arrow, the point of the arrow is with the x? You want that to be true in your solution as well. So what this is saying, instead of x equals negative 5, it's saying that x can be anything below negative 5. Any number that is below negative 5 can be a solution to this inequality. So with inequalities, a lot of times you're asked to graph the solution because it's not just one number, it's lots of numbers. So I want to show you how to graph an inequality. If you're planning to go on to college, you're going to need to know this skill. This can also show up on a test where you have a graph and you have to read the graph. So let's go ahead and get the skill right here. The first thing you want to do is draw yourself a graph. Draw yourself a number line and you put arrows on both ends to show that these numbers are going on forever. And there's a little symbol that you need to know about. This is the infinity symbol. And what that means is that the number line is endless. If you see that infinity symbol, it means it's going in the positive direction forever and ever. And then this is just showing you that it's going in the negative direction forever and ever. So if you see those symbols, that's all it means. It's not anything to worry about. It's just telling you that it's endless in both directions. The next thing I like to do, and my college professor taught me to do this, is put 0 on the graph. Because positive and negative depends entirely on the position of 0. So I always like to see 0 on my graph, just from habit. So where would our solution sit on this graph? If that's 0, negative 5 is going to be 1, 2, 3, 4, 5 spaces below 0. So here is negative 5. So I'm just using 0 as a reference. It has nothing to do with this problem. The negative 5 comes from that standardized solution. So we draw a circle. You need to draw a pretty large circle right there at negative 5 because that is our point of reference. And this inequality, I will do that, guys. I'm going to keep saying equation because I'm in the habit of it. It's an inequality. It's not an equation. Anything less than negative 5 can be a solution. So negative 6, negative 8, negative 100, anything below negative 5. So we call this an open interval. And I'll show you a closed interval soon. Just bear with me here. This is an open interval where x is less than negative 5. Here's why I wanted you to standardize. If you're in the habit of standardizing, you've got this. The direction that arrow is pointing is the direction you color. If it's pointing to the left, you color to the left of your negative 5. If that arrow were pointing the other way, you color the other way. So if you've got your solution in standard form, you don't have to worry about which direction you need to color. Okay, if you need to, stop this video and watch that example again. If you're confused, I want you to watch that example over again. If you're feeling pretty good, let's go on to number 2. This time I have negative 1 plus r is greater than or equal to positive 4. So I'm going to draw my power t just like we always do. And I'm going to decide which side is variable and which side is constant. And then I'll ask myself what needs to move. Well, the 4 is constant, the r is variable, but this 1 needs to move. So let's move it over here with the variables and cancel and copy. And so I have greater than equal to 5. And that's already standardized because that variable was on the left to start with. So we're ready to graph this solution. R can be 5 or anything greater than 5. So let's graph. This is new, so let's go slowly. We want to draw a number line and indicate that it's endless. Let's put our 0 down as a reference point only. And this time we're dealing with a positive 5. So we're going to count 1, 2, 3, 4, 5 above 0. And this is where you draw your circle because that's your solution. This time, however, I have a closed interval because 5 could be one of the answers. 5 is included. And the way that I know that is because I'm dealing with greater than, equal to. Up here, I was just dealing with less than. There was no equal to. So with a closed interval, you fill in the circle. You color it in completely. And that lets the reader know that 5 is one of the solutions. And then look at your arrow, it's pointing up the line. So 5 and anything greater than 5. So 6, 7, 8, 100, 1,000,000, those could all be solutions to this inequality. So there's the difference between an open and a closed interval. If you have greater than, equal to, it's a closed interval. Okay, here is number 3. We have negative 3x is greater than positive 3. So we're going to draw the power t. And put variable down and constant. And then we ask ourselves what needs to move. And it is the coefficient negative 3. Now something very strange happens here. If you divide by a negative number, or if you multiply by a negative number, something happens to that arrow. And let me just write it down. I am dividing by a negative. This is only with inequalities. It is not with an equal sign. You reverse your arrow. So here's what's going to happen. Because I'm dividing by negative 3, the arrow turns the other way. And I don't have a trick for that. You just have to remember to do it. And I forget it myself sometimes because I don't work with these. So x is now less than negative 1. And that only happens when you multiply or divide by a negative, that you will reverse that arrow. So this is standardized. We don't have to do any more reversing because we already have a standardized solution. We're ready to graph this thing. So let's draw a number line. These will always be graphed on a number line. And let's put in our 0 just as a reference point. I just like to see it. And then we're going to go 1 below that and draw our circle. And it's an open circle because this has no equal sign. It's just less than, so we leave it open. And the arrow tells me to go below negative 1. So there's the graph. You've got the open circle at negative 1. It is an open interval. And you're graphing below that because in standard form That's the direction that arrow is now pointing. X is less than -1, smaller than -1. Okay, number 4. We have 0 is greater than equal to 7n. So let's draw the power t. Decide which side is constant and which side is variable. And then what needs to move? And it is the 7. So we're going to divide both sides by the 7. It's not a -7, so you don't have to reverse anything. 0 divided by 7 is 0. That is not standardized, so we need to standardize it. N is less than equal to 0. Remember to turn the sign when you standardize. Okay, so let's graph. We start with a number line. That's not a very straight line, is it? And let's put the arrows to show that it's endless. I like to see 0 as a reference point, but this time 0 is the solution point. So we're going to draw our circle at 0. It does contain equal to. It's less than equal to. So we close the interval. And the arrow in standard form tells me to go below 0. So anything in that green area less than 0 is a solution to this inequality. Let me just show you something here. If these were your multiple choice answers, let's do 4 of them. Let's say n is 5, n is 1, n is 1200, or n is -3. Which one of those n's is in the solution? Which one of them is less than 0? Well, of all of those choices, only this one would be in that green area. So that's how they could ask you on the test. They could give you the inequality to solve, they could give you the graph to look at, or they could give you both. It could be any way. What if I put this one in there? Could n be 0? Yes, it could, because this is a closed interval. So you would say that both of those are solutions to this inequality. Anything 0 or below. Okay, number 5. I need to turn the page. This one I have k over 4 is less than -4. K over 4 is less than -4. So let's draw our power t. I am going to put a ghost 1 in front of that k to give me a numerator. And then we need to, first of all, decide that this is variable. And I don't want to move the k, I want to move the 1/4. So let's do 4 over 1. This is not a negative number, so we don't have to flip anything. So X that out, cancel. K is less than -4 times 4 is -16, and there's a 1 on the bottom. This is already standardized for me, so K is less than -16. There's the standardized solution. So let's draw a number line. And I like to see 0. That is not a requirement. You don't have to do it to make the graph correct. Negative 16 is pretty far below 0. I'm going to give some space there. You don't have to count them off. We're just showing an approximation of the position. So this is my solution. This is where I draw my interval marker. It's open because there's no equal to involved, and we're going below that. So less than negative 16. Seems like all of these, no, we had one that was greater than. It's just chance. I just made these up, but they all seem to be pointing the same way. Okay, number 6. Let's do m over 5 is greater than equal to negative 5. And here is the power t. We have variable on this side, so it's already standardized, and constant on this side. And let's put a ghost one right there. So we don't want to move the m. It's already on the variable side. I want to move the 1/5. And I do that by its reciprocal. Always the inverse. So we're going to cancel and copy. Negative 5 times positive 5 is negative 25, and we have the 1. So m is greater than equal to negative 25. We didn't multiply by a negative, so you don't have to reverse anything. You just keep it in the form it came in. Draw your number line and put your arrows on there. And let's put 0. That's important to me. Maybe won't be to you. I believe one of my college professors made us do that, if I remember correctly. Okay, negative 25 is below 0. And that's where the interval marker goes. This time it is greater than equal to, so we're going to color that circle. It's closed. And the arrow is telling me that it's anything above that line that would be the solution. So 0 would be one of the solutions. So would negative 20 or positive 20. Anything above negative 25. Okay, number 7 is negative 13x is less than negative 156. So I can already tell you that this will be an open interval because there's no equal to. Draw the power t, and I have a variable on this side, so we're already standardized. I have a constant on this side, and I ask myself what needs to move, and it is that coefficient. Be careful, it's a negative 13. I am dividing by a negative, and when I divide by a negative or multiply by a negative, what happens? The sign reverses. And I am not going to go into why that is. Your college professors may, but I doubt it. Just trust me, you do have to reverse the arrow. And then you just carry on about business. So I have x is greater than negative 156 divided by negative 13 is 12. And that is already standardized. You can use your calculator on these. These are not TABE problems, they are my problems, so I'm telling you it's okay. And then let's draw an arrow on both ends. Let's mark 0 and positive 12, that's above 0, so that's up here. And here is the interval. It's open, and then the arrow is telling me to go above the interval. So anything above 12 is a solution. Okay, number 8. We have 3 is less than negative 5n plus 2n. So let's draw our power t. And this time we have constant on the left, so it is not standardized. And we have 2 variables on the right, but they're both n's, so we can work with that. As long as they're the same letter, we're okay. So the first thing I'm going to do is to combine those variables. They're together, we just need to put them together even more. So negative 5 plus 2, that's negative 3n and 3. So then I need to divide by, there it is again, negative 3. And as soon as I do that, that arrow has to reverse. You have to reverse the arrow. So just like in this problem, we reverse the arrow. We're doing it here because we're dividing by a negative. Cancel the coefficient, so you're left with n, and then on this side is negative 1. If you want to standardize that, and I do, remember that the arrow flips again in standard form. So we've got n is less than a negative 1. So we have zero, and so negative 1 would be about there. I'm going to draw my interval. It is open, and then we are going below that interval. So n is less than negative 1. That one's tricky. All that flipping around is tricky. You might want to watch that one twice. Okay, let me see how many of these there are. I believe I gave you 14. I did, so we have 6 more to do. And I need some paper. I thought that might be coming. Let me just borrow some from this chapter. I'll need 2 sheets, I believe. So, okay, here is number 9. We have 6x plus 2 plus 6x is less than 14. And I'll tell you what, I need some space here, so let me just bring that on over. Draw your power t. And the variables are on the left, so we're in standard. The constant is on the right. But remember, this is not variables and constants. We need to get them down to just one of each. So I'm going to take 6x plus 6x to get 12x plus 2 is less than 14. I'm going to subtract 2. You do not flip the sign. It's only when you multiply or divide, and I'm subtracting 2, not multiplying or dividing 2. So you don't have to flip the sign. You copy and then divide by the coefficient. The coefficient's positive, so you don't have to flip the sign here either. So we're left with x is less than 1. And it is already standardized for me. So I can graph it. Let's put a line down and mark 0. Positive 1 is going to be right up here, and that's where you draw your interval. It's an open interval, so we're going to graph anything less than that circle. Does not include 1, but anything less than 1. Okay, number 10. I have negative 3 minus 6 parentheses 4x plus 6 parentheses is greater than negative 11. So the first thing we need to do is get rid of parentheses. We need to distribute. So we multiply negative 6 times 4. That's negative 24x. Negative 6 times positive 6 is negative 36. And if it helps you guys, go ahead and mark out all of that. Cancel it if it helps you. And then copy the negative 3, the greater than, and the negative 11. So you cancel and then you copy. And now I'm ready to draw the power t. Now that the parentheses are gone, we can draw our power t. Okay, so we have variable on this side. It's the negative 24x. So we'll move all of our constants over to this side. But before I can move the 3 and the 36, I need to pack them up together. So let's do negative 3 minus 36. That's going to be the negative 24x comes down minus 39. That's this blue part. And that is greater than negative 11. So we add 39 and we add 39 and we cancel. So you have negative 24x is greater than negative 11 and 39. Something is wrong here. Oh my goodness, guys. This is supposed to be 111. I am so sorry. Make that 111 and this will work out. Then this would be a negative 72. I'm sorry. I forgot to put that other one on there. Now be careful because you're dividing by a negative, so the sign has to flip. And go ahead and do that or you'll forget it. Just reverse the arrow. So you have x is less than negative 72 divided by negative 24 is positive 3. And that's standardized. And we are ready to graph the solution. So on the number line, arrows, put your 0 down there so you know where everything should be. Positive 3 is up here. That's where the interval starts and it's open. And we're going below the positive 3. So anything below that circle would be a solution to this inequality. Okay, number 11. I have 5 parentheses 6 plus 3r parentheses plus 7 is greater than or equal to 127. So let's get rid of parentheses before we do anything else. 5 times 6 is 30. 5 times positive 3 is 15 with an R. And then I'll copy everything else. You can cancel out that if it helps you. Power T comes right down through here, and the R is on the left, so we'll call that the variable T. The constant is on the right, so we'll call that the constant T. And I need to pack up some like terms before I try to move them. I've got this 30 and this plus 7, so let's make that 37. So I have positive 15r plus 37 is greater than equal to 127. Then move the 37. We're not multiplying and dividing, so we don't reverse our sign. We're just subtracting it off. So you're left with positive 15r, and then on this side you have a 90. You're dividing by a positive, so you don't have to flip anything. So in standard form, r is greater than or equal to 90 divided by 15 is 6. So your line goes down, and you need some arrows on there. Here's 0. Positive 6 would be above that, so up here somewhere. This time the interval is closed, and we're going above the circle. So the 6 and anything higher are your solutions to this equation, inequality. I told you I would keep saying it. I get equations stuck in my head, and then it's just... Okay, we have 3 more to go, and they're Lulu's, so just hang with me. I know these are getting harder. Okay, number 12. I have 28 minus 7x is less than equal to negative 4 parentheses negative 7x minus 7 parentheses. We need to get rid of parentheses first. Be careful, because you're multiplying by a negative 4. Negative 4 times negative 7 is positive 28x. Negative 4 times negative 7 is positive 28, but there is no x. Then you copy 28 minus 7x is less than or equal to this side. Draw your power T. You have 2 variables separated. You've got negative 7 on the left and positive 28 on the right. The positive 28 is your boss. So I am going to go ahead and move that 7x while I'm looking at it over here. Cancel, copy, and I'm left with positive 35x's. And there sits that constant. And this is the constant team, so that constant needs to move over here. So subtract 28, subtract 28, you're left with 0, 35x. So we're going to divide, but it's a positive 35, so we don't have to reverse anything. So x, let me just go ahead and follow the form and then we'll standardize it. 0 divided by 35 is 0, and then an x on this side. To standardize it, you have to reverse. Remember to keep the arrow going the right way. It's pointing at the 0, so we don't want to change that. And then here is the graph. All that work and we just got a 0. That kind of irritates me. Okay, so you draw your 0 and that's where the interval goes. So we put it right there. It's open and we need to shade above the 0. Look at standard form to know where to shade. And it goes above the 0. Alrighty, number 13. I have 28 minus k, and you can go ahead and put a ghost 1 with that if you want to, is greater than equal to 7 parentheses k, put your ghost if you want it, minus 4. Some people don't like the ghost, so it's entirely up to you. If you don't want it there, don't put it there. We have parentheses to get rid of. So 7 times 1k is 7k. 7 times negative 4 is negative 28. And then we copy. And now that the parentheses are gone, I can draw the power t. So I have a 7k and a 1k. The 7k is my boss. So let's go ahead and move the 1k. Let's take plus 1k and plus 1k, cancel, copy, 8k minus 28. So here's the constants team. And I'm going to add 28 to both sides, cancel. I get 56 is greater than equal to 8k's. Divide by 8, positive 8, so nothing reverses. We end up with 7 is greater than or equal to k. And in standard form, that looks like this. I'm not changing the value. I'm just turning it around so that it's in standard form, because that lets me know which way my my shading needs to go. Okay, so we are looking at 0 as a reference. Positive 7 is up here. That's where the interval starts. It is a closed interval. And we shade below the closed interval. That was a tough one, guys. All right, number 14. I have negative m minus 4m. And I'll tell you what, with that negative m, I'm going to go ahead and put a ghost in there. You can do what you want. Is greater than negative 10. No parentheses this time, so I can go ahead and draw. I don't even have to worry about the boss variable because they're both on the same side. I do need to combine them though to get a total of negative 5 m's. And then the constant is over here. So we have to divide by negative 5. And you know what that means if you divide by a negative or multiply by a negative. You reverse your sign. So instead of greater than, the sign becomes less than. And we have m and positive 2 already standardized for me. That's nice. So at least I just have to reverse it and I'm done. And here's the solution that I want to graph. 0, positive 2, interval is open, and I go below the circle. And there are 14 inequalities and their graphs. In the next video, we'll fill in our circles, and then we will be done with inequalities.